PET test is when you're comparing before and after. Example, very simple example. Okay, you saw the public nowadays are all my size, kan? Big size. Okay, 47% of the Malaysian population are overweight. So I'm not alone. I got so many friends who are overweight like me. Okay, so let's say you have an intervention method. Okay, you have an intervention method comparing before and after. Okay, weight before, weight after. Okay, in the middle you have the intervention. You expect if the intervention works, you expect the weight to be much less after. Betul tak? Okay. So let's take 104 kilogram. If the intervention works, you expect the weight to come down. Let's say 96 kilogram. 5 kg. Okay. So you minus 96 minus 104, you get, okay, oh banyak, 8 kg. Okay, you got 8 kilogram difference. So if everybody like this, everybody get a range of minus 8. So that is what we call the D, the difference. So when you're doing PET test, you are calculating the difference before against after. Okay. Okay. The formula D is difference minus 0. Doctor, why you minus 0? Why waste our time minus 0? That 0 is a reminder that if there is no difference before and after, the value will be close to 0. The difference will be close to 0. So that 0 only role is just to remind you, if the D is equal to 0, means no difference before and after. Okay? So what does it mean? If I go into training, and after the intervention my weight is still the same, so the difference equal to 0, so means no difference. So the concept here, now you want the difference before and after to be as far away from 0 as possible. The further away it is from 0, the more significant it is. So there's a formula. Unfortunately, you cannot calculate directly. Before you can get the t value, you must get the standard deviation. To get standard deviation, you have this formula to fulfill. Once you do this formula, then you can fill up this part, then you can get the t value. And from the t value, you can get the p value. Same like the before. Okay. Comparing the Hamdi score week 0 and week 6 for a group of psychiatric patient, or comparing HB level with amongst pregnant women after 6 weeks of treatment with hematinics. Okay, so these are some of the examples of the results. Okay. So here's a scenario given to you. Okay, how you should measure the BP for your patient? Does you measure the patient upon the patient coming into your room, or you measure the patient after the patient has been rested? By right should be has been rested. Okay, so so this one is a study trying to show that after the treatment, after resting, the BP will drop. So you have two measurement done. One upon entering the clinic, the other one after resting for 10 minutes. Okay. And the data looks like this. How many data set we have? We have a lot. We have 36. But only 35 is shown, only a few is shown here. The concept is BP before, BP after. So roughly you're saying, you can see that after they are rested, the BP drops. This one BP goes up. I think he saw his name was dropped from the nomination to be the Wakil Rakyat. So the BP goes up. Okay, so so forth. So this one better. He come down, he sit down, he saw a TV show that he liked, BP come down. What show? Suri Hatiku Mr. Pilot. So he was very happy. Okay. Because he see Nilofa on TV. BP drop. Okay. So I'm telling you, this is before, this is after. So how do you do this? You decide which one is supposed to be higher, which one is supposed to be lower. You decide that, okay, before should be higher, after should be lower. So you will minus before minus after. So you get this value. Then you square the values. 164, 163, okay, 1. So 164 minus 163 got 1. Why we minus before minus after? Because we expect the before to be higher than after. If you're doing a study on weight gain, you expect the population increase weight after intervention. Then after minus before. Okay. Okay. After that, you come up with the calculation. So please take note, we have the D, the difference, and the D square. And what happens with the D square? All the negative symbol goes missing. Nampak? Minus 2 become 4. Okay, so this is the formula. So you get the sum of the D. Then you get the sum of the D squared. Then you get the total number of the data. Okay. So here you put in all the values. To get the mean of the difference, it is the sum of the D divided by the total observed data. So 112 divided by 36. So you get 3.11. Standard deviation is a bit weird. Please take note here. Here is the D squared. So the D squared here is 1842 minus, in bracket, 112 square divided by n. Notice why you put square outside, so that you know this D and this D is different. Okay, this D and this D is different. So the D is squared, 112 squared divided by n, 36. Then n minus 1. Okay, this one is 36, this one is 35. So then you see you get the value of standard deviation of the difference of 6.53. Then you put it into this formula. Then you get a T of 2.8. 2.8 is larger than 1.96. Therefore, it should be significant. But of course, we have to be careful, because you have to refer to degree of freedom of 35. Okay, so let's refer to degree of freedom of 35. We don't have 35, but we got 30. So 30, we got 2.85. So 2.85 is between 0.01 and 0.005. So the p-value is between these two values. Doctor, why you don't look at the table A1? Because you got a small sample. You look at table A1, only you got sample larger 100 or larger. Anything less than that, you look at table A3. Conclusion, T equals to 2.858. Therefore, P is less than 0.01. Since P equals to 0.01 is less than 0.05, therefore null hypothesis is rejected. Yes, there is significant difference between first and second reading, and the first reading is significantly higher than compared to the second reading.